Legion, it is inhabited by the most ancient Medusian civilization encroaching on the solar system and dreaming of destroying humanity. There is no reason in another, if to believe the latest research planet, Barnard B, is an icy super-Earth, approximately 3 times larger than Earth. The temperature on its surface is about 170 degrees C. It is covered with mountain ranges and deepest gorges, and the object itself is outside the habitable zone. It is unlikely that this is the place where you would like to live. However, quite recently in the same location, 4 planets similar to Earth were discovered at once. It is possible that with them things are better. But first, let's answer the question, why we turn the gaze of telescopes specifically to the star Barnard and its environmental. Barnard's star is a very ancient object. Its age is 10 billion years, that is twice as much as the Solaris is a red dwarf belonging to a group of stars in large quantities inhabiting the universe. They differ significantly from their luminaries in their smaller size and luminosity. Barnard's star interested astronomers primarily in its proximity to the solar system. It's located 6 light-years from our luminary, is closer only to the Alpha Centauri system. Considering that red dwarfs are so common, the question of their life suitability has been raised by scientists for a long time. It is for this reason that the search for extraterrestrial life, or at least conditions for its emergence, is focused on red dwarfs and their planetary systems. What are the new planets near Barnard's star discovered by the Gemini North and VLT telescopes in March 2025? And why is this discovery especially important? The fact is that these objects are presumably rocky but very small. No more than 30% of the size of the Earth. The discovery itself is a unique phenomenon because tiny exoplanets are discovered extremely rarely. As a rule, they are very close to their star. Therefore, given the use of indirect methods of monitoring the universe, it is not so easy to find them as it was possible to do with the mentioned telescope. Of course, astronomers could not directly observe the planets. Accordingly, the objects were discovered by the changes that they make on the luminosity of the parent star when they rotate. Specialists analyzed the effect of the gravity of objects on the star Barnard, and thus found out how many exoplanets are near the star. There were 4 of them. But here scientists, especially astrobiologists, were expecting disappointment with almost 100% probability. It can be said that these objects are unsuitable for life, like the planet Barnard B, which we talked about earlier. However, the reason here is the opposite. The celestial bodies found are not icy, but on the contrary, very hot due to the dangerous proximity to the parent star. A year on these objects is only a few days. Therefore, despite the presence of a rocky surface, life in any form is unlikely to exist there. However, be that as it may, the previously expressed assumptions that more than one planet revolves around the red dwarf have also been confirmed, and we now know that in our immediate environment there are many more rocky worlds than previously thought. Is it possible to see Barnard's star or another red dwarf with the naked eye? It's paradoxical, but almost all the luminaries that we observe in our sky are white or blue. Thus, one can make the erroneous conclusion that there are extremely few red dwarfs, but this is not true. Simply to observe amazing objects, one needs special optics. The luminosity of such stars is very weak and the distance to them is huge. Naturally, it is problematic to see them with one's own eyes for this reason. Red dwarfs have been studied little, but now scientists are trying to correct the situation. Are red dwarfs of interest to astronomers only because there are an overwhelming majority of such stars and there are supposedly planets near them, or are there other reasons for active interest and they are significant? It is noteworthy that to this day not a singular dwarf has died in the universe. All of them are stably located on the main sequences of a conditional diagram, demonstrating the evolution of star stages of the life of a red dwarf, which is, Barnard's star is a gradual and very slow transition to blue, and then white dwarfs over time. Such a luminary contracts and heats up, and its lifespan can vary from several billion to tens of trillions of years. It is not surprising. Why are all red dwarfs still on the main sequence? Too little time has passed since the Big Bang for these stars to go through these stages and safely be reborn. What secret does Barnard's star hide? and in its face and the rest of similar luminaries, considering the antiquity of objects, you do not need to be an astronomer to assume that they arose at the very beginning of the birth of the universe. In this case, in composition of red dwarfs should be hydrogen and helium as well as very little metals. Not counting a tiny amount of lithium, ideally metals in the composition should completely absent. But in reality, this is not so. Spectral analysis indicates the metallicity of red dwarfs only, that the Big Bang model is again called into question. But scientists will always find a way out of the situation in attempts to adjust the discrepancy to convenient theories. Therefore, an explanation appeared. Astronomers decided to the mentioned paradox that the first supermassive stars died almost immediately after their formation, after a very short time after the Big Bang. The spherical process of death of luminaries filled space with materials including metals necessary for the birth of the next stars. Otherwise, according to scientists, most would have illuminated and would have remained at the stage of gas clouds, and would never have lit up. What can be said regarding the habitability of planets near Barnard's star? Those that have already found at the moment are most likely dead, but it is necessary to remember that the life cycle of a red dwarf is huge, much longer than that of yellow dwarfs like our Sun. Therefore, it is quite possible that in the future, the simplest forms of life on the surface of recently discovered planets will still appear. It is also unknown whether scientists will find any other planets near this star, and even those that will be in the Goldeye zone. That is, the potential habitability sector dwarfs will still bring us surprises. Rest assured, some astrobiologists believe that due to the amount of time for the development of life on red dwarfs in the future, it can become highly organized, that is, hypothetically, right now in orbits around these dim stars, civilizations immeasurably more developed than ours can live. Are there any problems associated with the conditions on the planets located near red dwarfs? If not counting the frightening bloody reflections of the star illuminating the surface with a ghostly reddish-orange light, there are certain nuances. Firstly, due to the low luminosity of such objects, the habitability zone automatically approaches to the star almost closely. But this is one of the main disadvantages that prevent the emergence of life. If the planet is very close to a massive body, in this case a star, then it will inevitably fall into tidal lock. That is, it will always be turned to the star with one side in the solar system. There are plenty of such examples. Earth and the Moon are the closest satellites of Saturn and Jupiter. This phenomenon causes a large difference between temperatures on the illuminated and shaded hemispheres. If the planet is surrounded by an atmosphere, then the effect is slightly smoothed out. If not, then one hemisphere will literally boil, and the temperature on the second approaches absolute zero. In such conditions, the only place where life will have the opportunity to develop is the boundaries between light and darkness, among other things. Red dwarfs pose a much more serious threat to their planetary system than the Sun due to their significant activity. Especially, large flares often occurring on the red dwarf can lead to complete sterilization of life if there is any on the planet. Unfortunately, the magnetic field of objects will not alleviate this situation in any way, because in tidal capture of planets, it is usually absent. Then the star Barnard differs from other red dwarfs. It is called a fugitive because the star has a high speed angular movement across the sky among similar objects such as not observed, and this makes Barnard's star recognizable for more than 170 years of observation. It has noticeably shifted and is now moving towards us at a speed of 90 kilometers in 11,018. That is still very not soon. Barnard's star will be in 3.8 light years from Earth. Of course, if by that time our planet will still exist, then the star will become our closest neighbor, provided that during the past time it has not developed any competitors. By the way, the flying feature of the star helps astronomers to detect planets around it. It is undoubtedly much easier to find large objects than very small ones, the gravitational pull of which is insignificant. However, the constant movement of Barnard's star significantly simplifies the process in any case. Having discovered the star, Barnard, a group of scientists from the University of Chicago, headed by Jacob Bean, made a promising discovery, indicating that astronomers are moving in the right direction and need to continue research. It is interesting to hear the voices of these planets. Perhaps the icy object Barnard B sounds like this, and small stone worlds send such signals to the universe. Is there a possibility to see these objects at least in the distant future? Unfortunately not. But it is worth it remember the failed unmanned mission called the Daedalus Project, the goal of which was to be Barnard's star. The mission opened up the real possibilities of interstellar flights, taking them out of the realm of fantastic inventions. The project was developed in the 70s of the last century by engineers of the British Interplanetary Society, and it is all the more surprising how in detail scientists managed to plan it in and take into account all possible nuances. In particular, according to calculations, the ship was supposed to reach Barnard's star in half a century after, studying the star and its surroundings, and the information was planned to be transmitted to Earth via a special radio channel. We remind developments were carried out from 1973 to 1977. Unfortunately, the project was closed since scientists encountered a huge number of obstacles associated not only with the technical imperfection of earthly sciences, but also with insufficient knowledge of the solar system, because the ship would have to overcome titanic asteroid belts, including the Cloud Oort. But why was Barnard's star chosen as the target of the failed project after all? There are luminaries located closer to us, for example, Proxima, Centauri. The reason is simple already. In those times, scientists were sure that planets revolve around Barnard's star, which there may be life, and now, we almost certainly know that these objects are dead, but scientists do not give in to difficulties. They continue to look for opportunities and develop projects in order to improve the life of humanity and move progress from a dead point. Let's help them throw in the comments scenarios on how to quickly get to Barnard's star and see how many planets there really are around it.